All right, guys, so we're going to start a new unit, continuous distributions. That's this stuff. Last unit was discrete distributions. This is continuous numbers. And if you've forgotten what continuous are, we'll kind of do a quick review of those. They're numerical variables whose values fall within a range or an interval. So discrete was like one puppy, two puppy, three puppies, four puppies, that sort of thing. That's discrete. Continuous would be anything on a line, something like that you're measuring on a number line. So it could be the height of a person. He's 61.52 inches tall. Usually it's going to be something you would measure. So temperature, height, time. That's what we're going to be dealing with these continuous distributions. And they can be described by density curves, which is what we're going to look at quite a bit. A density curve is just a line with area underneath it. That's all a density curve is. It's not scary, I promise you. It's going to just deal with area. So when you think of area, like hopefully you don't get frightened. It's just, basic geometry for the most part. So for our density curves, and just a quick reminder, the notes for this unit are always available on the Week at a Glance or wherever your teacher has it. And they follow along with the PowerPoint. It's just meant to help you out to know what to take notes on, what's important. You don't have to use it. I just think it's helpful. So density curves are always going to be on or above the horizontal axis. So they'll always be above the x-axis or on it if it's 0% chance of that happening. The area underneath the curve has to add up to 1, always. The sum of the area under the curve has to be 1. End of story, every single time, because everything has to have a total of 100% chance of occurring. Something has to have 100% area, otherwise it doesn't make any sense. Something has to happen. Let's see this. And what we're going to do is we're going to describe the proportions of these observations that fall within different ranges. So we're going to say, like, what's the chance of being between 3 feet tall and 4.7 feet tall? And then we will find the area between those. We're going to start off today and I think tomorrow focusing on uniform distributions and unusual distributions. It might just be uniform. I might have confused myself with AP statistics. But uniform distributions are continuous distributions that are evenly or uniformly distributed. They're going to be a flat line. Everything has an equal chance of occurring. So it's going to look like a rectangle. All the area formulas are going to be based off a rectangle. So this is a pretty good, I think, place to start with continuous distributions. You're going to calculate the probability by finding the area underneath the curve, which in this case is just a flat line. And this is pretty important. How do you find the area of a rectangle? Pause for a second for some reflection. And hopefully you came up with base times height. Base times height. Here are two formulas that are probably worth writing down. This is the mean formula. This is the average value, a plus b over 2. These are the endpoints of the curve. And this is the standard deviation formula. So we've talked about mean and standard deviation over and over again. Different distributions have different formulas. And here are the formulas for uniform distributions. They are worth writing down. You definitely need to write them down. Unless you have like photographic memory. You need to either memorize these or write it down. All right. Let's look at some examples, I think. Yeah, there we go. The Citrus Sugar Company packs sugar in bags labeled 5 pounds. However, the packaging isn't perfect, and the actual weights are uniformly distributed with an average of 4.98, so a mean of 4.98 pounds, and a range of 0.12 pounds. So the center of the distribution is going to be 4.98, and the total range from the left endpoint to the right endpoint is 0.12. And so that's going to look like this. This is what you would draw on a piece of paper if you wanted to solve this problem. You would put the middle at 4.98. Notice that they went 0.06 to the right, and they went 0.06 to the left. So the total distance across here, the total range, is that 0.12. From the middle, they went half the distance for the range, and middle, half the distance of the range. That's how they got these two endpoints. If we wanted to, we could find the height of this rectangle by remembering the area of the rectangle has to be 100%. So it has to be 1. If you already know what the base is, 0.12, we can solve algebraically for the height. It's 1 divided by 0.12. I can show you that algebraically if you're struggling with it. Let me get a piece of paper. Hopefully it makes sense, but if it doesn't, it's okay, and I will show you exactly where that came from. So if I tell you the area of a rectangle is base times height, and I tell you the area has to always be 1 in this probability situation, the area is always 100%, and you know your base, in this case 0.12, then algebraically, if you want to find the height, all you got to do is divide by 0.12. And you know it's true because it rhymed. So h is equal to 1 divided by 0.12. Now we can start answering different questions. For example, what's the probability that a randomly selected bag will weigh more than 4.97 pounds? In this unit, I highly recommend you get in the habit of drawing little rectangles and shading them, maybe lightly. We're going to draw and shade. So greater than 4.97. This is what my paper would look like if I were doing this problem. I would shade from 4.97. I probably mark down that this is 4.97, all the way to the right. We want to now find this area, and it's really easy because this is just a rectangle. We just need to figure out what is the base of that rectangle, how long is that rectangle's base, and we already know what the height is. It's 1 over 0.12. So we get 0.07, that's the distance from 4.97 till 5.04, times the height, base times height. So the chance of finding a bag that weighs more than 4.97 pounds in this situation is 0.583, 58.3%. There's not going to be too much else to this. I like it. If you're stuck on here, don't worry. You'll have some extra attempts to figure it out. And if you get this, congratulations, you've more or less figured out uniform distributions. Next, we want to find the chance of being between 4.93 pounds and 5.03 pounds. Again, I would recommend you draw, it doesn't have to be a beautiful picture, but a quick picture, shade between the two values you're curious about. Then we're going to figure out what is this distance between 4.93 and 5.03. You can use your calculator if you need to, or you can recognize it's 0.1. We get 0.1 times the height, so base times height, and that gives you the area. You're very likely, in this situation, in this factory, to end up with a bag of sugar between 4.93 pounds and 5.03 pounds. This is very likely to occur. The time it takes for the student to drive to school is evenly distributed with a minimum of 5 minutes and a range of 35 minutes. And it says draw the distribution. So we know what the minimum value is this time. And that's probably the trickiest part, is just paying attention to, is it giving me the middle value, the upper bound, the lower bound? What's it giving me? So minimum value is 5 and the range is 35. This time we're going to start off with the minimum and we're going to go 35 to the right because the range is 35. That's how we're ending up with these values. And after that, we're going to figure out the height. Remember, the area has to be 100%, so 1. This is 35, so the height has to be 1 over 35. And it's not going to change from that idea. The area of the curve has to add up to 100%, and you just divide that by the total distance. Next up, we could say, all right, what's the probability it takes less than 20 minutes to drive to school? I go to 20. I shade everything to the left. I overestimated where 20 was. Go 20, shade everything to the left, and then we just find the area of this rectangle. The length from 5 to 20, this distance right here, is 15. So base is 15 times the height, tells you the chance it takes you less than 20 minutes for the setup to get to school, 0.429. That's about it for that. Finally, for this situation, it wants us to find the mean and the standard deviation for that distribution. As long as you wrote down your formulas, you just do your endpoints, so 5 plus 40 over 2. That's the average. I'd like them to say minutes because it has a unit, but that's fine, 22.5 minutes. And the standard deviation formula is the upper bound minus the lower bound, b minus a squared over 12. And then that is the variance. I said standard deviation. That's the variance, sigma squared. To find standard deviation, you just square root it. So square root of that. It gives you 10.104. And that's about it for this. That's the end of today's lesson. We're just do some practice problems together. And good luck. And how do I stop recording? This is going to be in the video.